Unit 12, Day 5 notes. Today we're going to be discussing dimensional change. The first part of this lesson, we're going to talk about dimensional change based on two-dimensional figures. So I have three squares, and the first thing it wants us to do is find the perimeter and the area of each square. So as we should know by now, the formula for the perimeter of a square is 4 times the side. And the formula for area is s squared. So for square A, we're going to find the area of perimeter and the area of that one first. Again, sorry, we're finding the area for square 1 or square A first. At perimeter. So the perimeter for A is 4 times 2, so that is 8. The area for A is 2 squared, which is 4. Now let's do the same thing for B. The perimeter for B is 4 times 4, which is 16. And the area for B is 4 squared, which is also 16. And now for C. The perimeter of C is 4 times 6, which is 24. And the area for C is 6 squared, which is 36. Now number 2 wants us to compare and contrast each square. How did the dimensions change from A to B? Well, from A to B, you can see that the sides doubled because 4 is 2 times as big as 2. So from A to B, the dimensions doubled. And then from A to C, the dimensions tripled because 6 is 3 times as large as 2. B says, how did the perimeter change from A to B and from A to C, and write the ratios? So the perimeter for A was 8 and the perimeter for B was 16. So the perimeter also doubled from A to B because 16 is 2 times as large as 8. So the perimeter doubled. It wants us to write the ratio of perimeters. So the ratio would be 16 to 8. And if I reduce that, that's 2 to 1. Now for A to C, the perimeter for C was 24. And 24 is 3 times as large as 8. So it also tripled. So 3 times as large. And the ratio would be 24 over 8, which reduces to 3 over 1. Now it's asking about how does the area change. So the area of A was 4, the area of B was 16. So it was 4 times as big. So it quadrupled essentially. So from A to B, the area quadrupled. In other words, 4 times as large. So if I were to write the ratio, it would be 16 over 4, which reduces to 4 over 1. And then from A to C, the area for C was 36. So if I were to take 36 and divide it by 4, that appears to be 9 times as large. So 9 times as large. So it's 36 over 4, which is 9 over 1. Very interesting facts. So we're going to take this triangle and this circle and compare and contrast the original, which we see right now, with the new figure that is formed after we do as it is described. So again, we're going to find the perimeter of the original and then the area and compare it to the new. So to find the perimeter, this is an equilateral triangle. I'm sorry, I should have mentioned that to you. So since it's equilateral, I could take 3 times 22, and I'm going to get 66. And then to find my area, it's base times height over 2. So that's 22 times 8 over 2, which would equal 88 units squared. Now it wants us to cut all the dimensions in half. So 8 would become 4, 22 would become 11. So the perimeter of the new triangle would be 3 times 11, which is 33. And then the area would be 11 times 4 divided by 2, which is 22 units squared. So the perimeter of the original is actually 2 times larger. But another way to look at it is the perimeter of the new is half the perimeter of the old. So the perimeter of the new is half the perimeter of the new. I'm sorry, of the old. And then the area, let's write the ratio. So it's 33 over 66, which is equal to 1 over 2. And now let's talk about the area. The area of the new looks to be 4 a fourth of the area of the old. It's a fourth the area of the old. And again, how do I know it's a fourth? To find the ratio, it's 22 over 88, and when you reduce that, it's 1 over 4. Please complete number 4 on your own. Do the same thing, find the perimeter, find the area, and compare the changes from new to old. Now we're going to get into solids and do something very similar. We have 3 cubes. They're all similar cubes, and we're going to find the lateral total area and the volume for each of these cubes. The formula from our formula chart for lateral of a cube is 4 times e squared. E stands for edge, everybody. And then for surface area, it's 6 times e squared. And then for volume, it is e to the third power. Now we can find the lateral total and volume for each cube. All right, so the lateral for cube A would be 4 times 2 squared, which is 4 times 4, so 16. The surface for cube A would be 6 times 2 squared, or 6 times 4, which is 24. And then the volume, I ran out of space, so I'll put it at the top. The volume would be, 2 to the third power, which is 8. Now for cube B, the lateral would be 4 times 4 squared. 4 squared is 16. 16 times 4 is 64. The surface area would be 6 times 16. I don't know that one off the top of my head. I believe it's 72. No, 96. My bad. And then the volume would be 4 to the third power, which is 16 times 4, which is 64 again. And lastly, for cube C, the lateral would be 4 times 6 squared. 6 squared is 36. 36 times 4 is 144. The surface for C would be 6 times 6 squared. So 36 times 6 is 216. And then the volume would be 6 to the third power. So 36 times 6, which is 216 again. Now time to compare and contrast. From cube A to B, the dimensions were doubled. Because 4 is 2 times 2, so 2 times as large. And from A to C, the dimensions tripled again. Again, 3 times as large. B, how did both areas change from A to B and A to C, and write the ratios? So going from 16 to 64 for my lateral, it's only 4 times as large from A to B. So my lateral is 4 times as large, and so is my surface area. So if I were to find the ratios, I would take the new, which is 64, put it over 16. It reduces to 4 over 1. And same thing with the 96 over the 24 would reduce to 4 over 1. The first one was the lateral. The second one was surface area. Okay. And from A to C, I'm going to guess it's going to be 9 times as large, but we're going to verify that in a moment. Let's find the ratio first. That would be helpful. So we went from 16 to 144. So if I take 144 and put it over 16, divide it out, it is 9. That was the lateral. And for surface, it's from 216 to, or it went from 24 to 216. And again, I bet this is going to be 9. Yes. So it is 9 times as large. There should be some patterns you might be able to pick up on as you're looking at some of these. But if not, we'll summarize them in just a moment. Now C is asking for the volume from A to B and A to C, write the ratios. So volume for cube A was 8, volume for cube B was 64. So that looks like it's 8 times as large. So it's 8 times large. So 64 divided by 8 is 8 over 1. And then from A to C, it was it became 216. Oof, that's a large one. So let's find the ratio first. So 216 divided by 8 is going to give me 27 over 1. So it's 27 times as large. Wow. So you're gonna take this sphere and this cylinder and do the same thing. Compare the dimensions and describe the changes of area and volume. For the sphere, and the cylinder, only calculate the surface area. Don't worry about the lateral. Do those on your own. So in summary, the little ratio that we were finding, that's also known as your scale factor. So that's what, when you see SF, that's what it stands for. This is your scale factor, which was the ratio that we were finding, the reduced ratio. Notice the exponent is going to match the unit's exponent. So when we found perimeter, that was a one-dimensional thing. It's a distance around. So you just take whatever the original perimeter is times your scale factor, and that'll give you the new scale factor all the time. To find the new area, this is for 2D objects only. You just take the scale factor and you raise it to a power of 2 and multiply that to the original. So let's say, nah, never mind, let's not say anything. These are just the rules that you just should know. To find the new lateral, again, since it's area, which is two-dimensional, you're going to take your scale factor, raise it to a power of 2, and then multiply that number by your original lateral area. And to find the new total area, again, since it's area, take the scale factor, raise it to the power of 2, multiply that by the original. And then we get to volume. Volume is only for three-dimensional objects. And when we write our volume units, we use to the third power. So you're going to do the same thing with your scale factor. Take your scale factor and raise it to the third power. And then multiply that by the old volume. So don't just take the scale factors and follow these steps. After you do these steps, you still got to multiply this by the original. So times original for every one of these situations. Okay, and so on and so forth. But these are shortcuts to finding the new areas, only given an area or a dimension. And this concludes your notes for today. Please finish those examples I did not. Take a picture and submit.